Our process rather, it's just a better way of making cement. And lower carbon, yes, but there are also a much broader range of environmental benefits. When you compare a typical cement plant and Sublime, there are lower particulate emissions from our plants. You've got lower NOx and SOx emissions that can contribute to acid rain. And so, like, for example, at our Holyoke plant, there's literally like a senior center across the canal from us. And for a typical cement plant where you've got the noise, particulate emissions, the heat, like all of these kind of scary things from a cement plant, the Sublime process and plants, it's just a better, smarter way of making cement.
Hardware to Save a Planet explores the technical innovations that are giving us hope in the fight against climate change. Each episode focuses on a specific climate challenge and explores an emerging physical technology solution with the person bringing it into reality. I'm your host, Dylan Garrett. Hardware to Save a Planet is brought to you by Synapse. Make sure to click subscribe so you don't miss any future episodes. Thanks for listening. Hello and welcome to Hardware to Save a Planet. I'm excited to have Greg Williams, VP of Product at Sublime Systems today. Sublime has developed a process to dramatically reduce the emissions from cement production. This is a big deal because making cement accounts for 8% of global emissions today. I feel like at every climate conference I went to last year, so much of the talk was about cement, steel, and chemicals production. These heavy industries are essential to human life today. We produce this stuff in crazy big quantities, and that production accounts for a really big chunk of our emissions. So it's a really important place to focus, but these things are really hard to decarbonize. Sublime's approach eliminates the fossil-fueled kilns from the process and also the emissions from limestone decomposition by using electrochemistry to extract what they call sublime lime from raw materials. So they're able to power their process with green electricity. I'm looking forward to Greg hopefully elaborating on that a bit more for us in a minute. Greg has been on the Sublime leadership team since early 2023. Prior to that, he has spent his career building hardware and software products across a range of industries, from media to e-commerce, including robotics and AI. He and I first met 5 or 6 years ago when he was at Kindred, building intelligent robots for logistics. And I remember from that time that our team at Synapse, working with Greg, always spoke very highly of his leadership and collaboration. Greg, it's awesome to reconnect and really a pleasure to have you on the show. Thanks for joining us.
Yeah, my pleasure. Good to reconnect, Dylan, at this time from the other side of the country, but good to connect virtually.
Yeah, right. You're dialing in from the Boston area, right?
That's correct. Yeah.
So I always love seeing people come to climate-focused sectors from other industries. It looks like you came from a mostly e-commerce-focused career to Sublime, which is kind of this big industrial process with a climate focus. What motivated that move for you?
So I've done a number of things in my career. I started out as a mechanical engineer, worked in aerospace for a number of years. Then in grad school, I actually focused on operations and manufacturing. And then that led me to work at Apple on the manufacturing side, helped launch the first iPhone and a few follow-on products. And then I fell into startups. I was in the Bay Area, just kind of fell into that ecosystem, switched into products, and then ended up leading product teams, as you mentioned, at a number of startups of different stages across a few different industries. But this was all in the Bay Area. So I lived there for better part of 20 years. And over that time, I saw wildfire season go from 3 months a year to 6 months a year. And you could literally see it happening in real time. And, then I had kids, and obviously your priorities start to change at that point. And so a couple of years ago, I just decided I needed to prepare for that conversation one day when my kids asked me, what did you do about this problem? And so did a deep dive. I knew nothing about climate, and there was a lot to learn. Never figured out I would end up working in cement, but that's kind of where my path led me. And yeah, I joined Sublime about 2 years ago.
So you were sort of looking at where you could have an impact on climate, and that process led you to cement specifically?
Yeah. I mean, I literally started with reading Bill Gates' book, and that was my intro to climate and the impact on the economy. And then you kind of realize, well, climate is the entire economy. So like, where do you want to play in there? And so I looked far and wide, talked to hundreds of people across my network and extended network. Do I want to help with software? Do I want to be in atoms or bits? Basically, what sector of the economy do I want to be in? And one of the key criteria was I wanted it to be high leverage. Like I didn't want it to be skirting around the edges of the problem, but like actually have a meaningful impact if whatever we did worked. And as you mentioned, cement certainly fits that criteria. So it's been a learning curve. I work with mostly a team of incredibly smart PhD electrochemists and chemical engineers. I'm a mechanical engineer by training, so it's been a fun journey to kind of ramp up on the tech. But yeah, that's kind of what led me here.
Yeah, I was going to ask about that learning curve because cement, I assume you're VP of product. The product is this kind of cement replacement, so that Sublime Cement. Has that been a big learning curve for you to be in charge of what feels to me like a very different product than what you've done in the past? Or do a lot of the concepts translate? What does that look like?
100%. I mean, when I first interviewed with Sublime, I think I used the terms cement and concrete interchangeably to show where I was starting from. So yeah, cement is a commodity product. I certainly had never worked in commodity industries before. And yes, figuring out how to translate what I'd done building SaaS products and robotic products and consumer electronics products to cement and a number of other kind of co-products that we produce. It's been interesting. A lot transfers, but a lot doesn't. I think just the timelines, like recalibrating from software, you can push a new feature in minutes if you need to, or in a few weeks. Hardware, maybe there's a 6-month lead time in terms of being able to produce new prototypes. But now we're talking about a multi-year lead time to finance and build a plant. Meanwhile, your R&D team is making constant progress, improving the chemistry and composition and performance. And so figuring out how to reconcile those things to come up with a roadmap that is adaptable. And yeah, it's been an interesting journey.
Since you mentioned it, help us all understand when to say cement and when to say concrete.
So what's funny is those trucks that you see driving around with a big drum on the back. And as a kid, you call them a cement truck, right? And it's not cement. That's actually a concrete truck. So, I mean, cement is basically the glue that holds concrete together. So if you take cement, you mix it with gravel, sand, water, and some chemicals. That makes concrete. Cement is the binder, and concrete is what gets poured at the job site, what you see dumping out of the truck. So that's the main difference is cement is the glue. It's actually only about 10% of the volume of the concrete. The rest is the gravel and sand and water, but it is over 90% of the carbon footprint of concrete is from the cement.
And what is it about cement production that makes it so carbon intensive?
So you alluded to kind of the two main big reasons, but let's talk a little bit about how cement has been made for basically 200 years at this point. There was actually the 200-year anniversary last October of the filing of the patent for Portland cement. So it's been 200 years. You mine a bunch of limestone out of the ground, out of the quarry. You throw that with some clay and a few other additives into an enormous rotating kiln. This kiln is fired at 14 to 1500 degrees Celsius. And then what comes out the other end of that kiln is called clinker. It's basically these gray nodules that are about the size of a golf ball. And those get ground up into a powder and mixed with a few other additives. And then that is cement. And so the reason that process is so carbon intensive there's kind of two main drivers. Number one, since the kiln has to be fired at such a high temperature, I mentioned like 1450, 1500 C, the only way you can achieve those temperatures at industrial scale today is typically by burning coal or natural gas. And so that is roughly half of the emissions. Then the other half is limestone, it's calcium carbonate. And it's roughly half its weight is CO2 that's trapped in the rock. And so when you thermally decompose that limestone inside the kiln, all of that CO2 is released to the atmosphere. And so that's roughly the other half of the CO2 intensity of the cement making process.
And then I guess the other thing that just makes it such a huge contributor to our total emissions is just that we make so much of it. I was trying to find some stats on this, but one thing that stood out to me is half of all human-generated material on Earth by mass is concrete today.
Yep. I've heard that stat as well, that we've now produced more concrete than the weight of all living thing that's ever lived on the earth or something to that extent. So we produce a lot of this stuff. And so even though, on a per volume basis, concrete isn't that bad, the sheer volume makes it that 8% of overall emissions. You're absolutely right.
And sounds like over 200 years, the process just really hasn't changed all that much.
That's correct. And there's a lot of innovation going on in the space in a lot of different ways, beginning to use alternative fuels, like burning old tires instead of burning coal to fire the fuel. And so you're beginning to see a fair amount of that, especially in Europe. So that's beginning to have an impact and drag those GDP down. Carbon capture and sequestration is getting a ton of investment. And a lot of the cement majors they've got multiple pilot projects up and running. So trying to capture the CO2 as it's emitted from the stack. So those are a couple of the other tactics. Another one is just use less cement in concrete. So you can mix in what are called supplementary cementitious materials, or SCMs, into concrete, and that can replace some percentage of the cement. A few examples of these are fly ash, which is a byproduct of power production, or slag, which comes out of steel making. And so these materials, you can replace typically up to maybe 30% of the cements in a concrete mix with these materials. And so that can also help. So there are a number of different ways to try to reduce that carbon intensity, but it's all incremental, kind of fractional improvements. And so that's why Sublime was founded, was to try to address the root cause of that CO2 intensity and get more to a 90, 95%, 100% reduction as opposed to 25 or 30%.
And was there some kind of fundamental new discovery that is driving Sublime's process, or is it more about the cost of renewable electricity coming down and not making it more possible? Like, what has changed to make this possible today after 200 years?
That's certainly part of it, but I think that the company was founded, our two co-founders, Professor Yet-Ming Chang out of MIT, he's kind of a serial entrepreneur. I think Sublime was his 7th or 8th company that he's founded. And prior to Sublime, all those companies were battery technology companies. So he's a battery scientist. Our CEO, Dr. Leah Ellis, she was a postdoc in his lab. She also was a battery scientist. And so they came at this problem from the perspective of, okay, we have all this new renewable energy coming onto the grid. And what could be done to fight climate change beyond just putting it into a battery? What other challenges could we use electricity for? And so they came up with the idea of trying to see if we can produce cement with electrochemical means, get rid of the kiln, get rid of fossil fuels, and see if you can make a cement. And so that was where it started about 5 years ago. And now we have a pilot plant operating here in Somerville. We can produce over 100 tons a year of cement, which we're using for our initial field pours and demonstrations. So we can pour 1 to 2 trucks of concrete to do small projects at scale. The availability of clean energy and that cost coming down the curve is a huge enabler of a technology like ours to hit scale.
And can you just walk through your process and how it's different?
Yep, absolutely. So a colleague of mine has this great analogy of, he thinks of Sublime cement production as kind of the ceviche way of like cooking fish, as opposed to putting it in the oven and like using natural gas or something to cook it. So we basically take non-carbonate feedstocks. So these are rocks and minerals and byproducts that don't have that trapped CO2 like limestone does. And those feedstocks, we put them into our process, our electrochemical process. They basically are digested, kind of stripped down to the constituent mineral elements of those feedstocks. And then we can precipitate those out into individual components. And so this is a purifying process, so we can eliminate and remove any chemicals that are not useful in cement chemistry, like iron, for example, or magnesium. And the 2 main components that we produce are a lime. It's actually a hydrated lime, calcium hydroxide, and then a reactive silicate. And so those are the two primary ingredients that we then blend together. These are free-flowing powders that are produced out of this process. You blend those together along with a few other additives to produce Sublime cement. And so with Portland cement, it's kind of like a one-part epoxy. Like you get the calcium and the silica out of this clinker that you grind up. And when you add water, it produces a hardened state called calcium silicate hydrate. And that's what gives concrete its strength. We form the same calcium silicate hydrate in concrete when you mix Sublime cement with water, but it comes from kind of a two-part epoxy, the calcium from the lime and the silica from that reactive silicate. So when you look at concrete that's produced with Sublime cement versus Portland cement, it's extremely similar. It's just that we get to that final state via a different path.
So does that mean the actual like concrete production process, where today they're mixing Portland cement with, like you said, gravel and other things, does that process have to change, or is it literally is your product a drop into that process, that existing process?
So we are designing it to be a drop-in replacement. And so what that means is we comply with third-party industry standards like ASTM standards for cement. From the moment we ship the cement from the gate of our factory, everything downstream in the supply chain and the actual deployment of cement in concrete is the same. So it can be shipped in the same bulk trucks, stored in the same silos, batched in the same concrete mixers and trucks. You place it, pump it, pour it, finish it the same. It sets in a similar fashion, develops strength in a similar fashion. So that is the idea, is that there is very little to nothing that needs to change for the concrete producer, the contractor, the GC, the engineer. It's an easy swap.
So it sounds like you're eliminating, like you said, kind of the two big sources of emissions from the existing process, the fossil fuel kilns and the CO2 that's released from the limestone. You also mentioned these other processes. I was curious about carbon capture specifically, because you said that's a place that's getting a lot of investment and attention. From a climate standpoint, how should we be looking at what you're doing, where you're kind of avoiding the emissions in the first place versus just capturing the emissions from cement production and then storing that? Like, why would this be better, or why is one better than the other?
First of all, carbon capture is, I would say, still to be proven to be economical and effective at scale. There are a lot of pilot projects that are being built out right now. It's an exciting technology. Like we need all of these solutions in the industry. No one is going to get to scale fast enough to solve the problem. So we root on these projects just like we do our own internal teams. But there's a lot of cost and complexity that comes with carbon capture. It can double the cost on a per ton basis of producing cement, can consume a lot more water, which is another precious resource. There is logistical complexity that comes with, like, once you capture the carbon, you have to do something with it. And so most cement plants are not built on top of rock formations that are suitable for storage of CO2 for 1,000 years. And then there isn't a ubiquitous network of CO2 pipelines built out to transport this material to where it can be sequestered. So there's the whole logistical complexity and cost downstream once you've actually captured the carbon. And for the majority of these projects, it's not capturing 100% of the CO2. There's still some emissions, so it's not fully effective. So again, like, tremendously helpful, can be a great tool, but our philosophy generally is if you can avoid even emitting the CO2 in the first place, eventually that is going to be a much cheaper, simpler, and more scalable solution. And you'll get kind of closer to that 100% reduction magic number.
So at the end of the day, yeah, just that's fundamentally a new process and cost that's going to be built into the cost of green cement based on carbon capture. And you project that Sublime cement can get to sort of cost parity with Portland cement?
We do, eventually. It's going to take some time. Like any new technology, we have to come down that cost curve as we scale. As mentioned, Portland cement has had 200 years to cost optimize their process. And your typical Portland cement plant is producing at least 1 million tons per year of cement. And we are operating at less than 0.1% of that production scale right now. But yes, we have plans to build plants that are at similar scale. We have been fortunate enough to form partnerships with a couple of the actual cement majors that will help us to do so. And once we do achieve a similar level of scale, our models show that we have a path to cost parity with that cement production. The first full-scale plants, our target is having cost parity with the cost of OPC production if you include the cost of carbon capture, and then beyond, at some point, getting to pure parity with just cement production, even when you don't take the carbon capture into account.
And that's really just economies of scale, or is there something else that has to change, like the cost of energy coming down further or anything like that?
We're not counting on the cost of energy coming down further. It is scale primarily, and then technology learning curve. I mean, if you look at any technology from first plant to 10th plant to 100 plant, you improve efficiencies. There are kind of second and third generation versions of our own technology for certain steps of the process that we're already developing internally that will significantly reduce their energy consumption and therefore the cost of the process. So it's both economies of scale, but also just continuing to improve the technology and make the overall end-to-end process more efficient so it uses less electricity.
From a kind of technology innovation standpoint, it sounds like the cement itself, there's a lot of innovation and probably development work going into that product. I was curious about the hardware and physical technology around producing that product. To what extent are you innovating in the electrolyzer itself? Or is this really more about sort of process design and plant engineering? Where is there innovation or kind of interesting technology development happening outside of the cement itself?
There is innovation and IP being developed both on the product side, like the actual cement blend developments and the chemistry of the cement blend itself. How does it hydrate in water? How do we achieve similar levels of strength with much lower carbon intensity? On the process, we are actually intentionally trying to use proven existing technology wherever possible to allow us to get to scale as quickly as possible with minimal technology risk. We have to raise a lot of money to build these plants. And so a big part of convincing project financiers to fund a large-scale construction project is showing that there is little to zero technology risk. And so using proven technology wherever possible is a big part of that strategy. Now, that being said, as mentioned, that's for kind of Gen 1 to be able to initially get some first plants built, get to CL, finance those. But long term, there absolutely is Sublime proprietary technology across multiple steps of this electrochemical process that is being developed internally that will be a big part of how these plants come down in cost over the years. I will say parts of it are very similar to traditional cement plant. So like we require grinding and milling and solids handling equipment just like a cement plant. So that portion, which I think is roughly 30% of the overall cost of a plant, like we are very much intentionally just using the same sort of equipment and processes that a traditional cement plant. It's everything upstream of that is a little bit different for Sublime.
So like you'll eventually be developing Sublime electrolyzers, for example, and other components of the system.
Yeah, the electrochemical Sublime portion of the process, the electrolysis, the reactors, there is proprietary technology being developed across that. That is correct.
Okay, cool. And how mature is the system today? It sounds like you have a pilot producing cement and your concrete is being used somewhere today. Can you talk a little bit about this?
Yeah, so we have a pilot plant that's operating. It's in our own kind of headquarters facility in Somerville, can produce 100 to 200 tons a year of material, basically enough to do small demonstration projects. We use that to validate that what's coming out of R&D can scale, produce that material for demonstration pours, send samples to potential off-takers, those sort of things. In parallel, we are in the design phase for our first commercial scale plant. So you may have seen something in the news about this at some point, but we are building a roughly 25,000 ton facility in Holyoke, Massachusetts. It's about an hour and a half west of Boston. Holyoke at one point was one of the paper capitals of the country. And so it's an industrial town. We have a site right on the Connecticut River next to a hydroelectric power plant. which is very nice when you're talking about an electrical process that needs kind of clean, cheap, renewable energy. We were fortunate enough to be selected for a grant from the Department of Energy to help fund the construction of this project. So that timeline is looking like that plant would be coming into production towards the end of 2027. So we're in the engineering design phase right now. The main objective of that plant is show that our process can scale from a little 100 tons a year pilot plant to a million tons a year, or what we call a megaton plant, that it can make that intermediate scale jump, de-risk the technology, and unlock financing for those kind of full-scale plants eventually that we need. And then in parallel, we're beginning to talk to our partners, Wholesome and CRH, which we announced these partnerships a few months ago, beginning to talk about potential siting of full-scale plants across a number of continents downstream. And so that's more like 2030 timeline for the first of those plants to hopefully come online. So that's what our scale trajectory looks like over the next couple of years. But with the material we have today, over the last year, we've done 4 different projects. So actually getting concrete into the ground that has Sublime cement in it. These are 10 to 20 yards of concrete. So again, 1 to 2 trucks. And starting simple with easy applications, sidewalks, those sort of things where there's not particularly demanding structural requirements. You're not building skyscrapers out of the gates. You've got to walk before you run, but prove that you can batch the material in a larger volume in a concrete truck and that it's going to pour and set as they would expect, and that they can schedule the finishers and the contractors around the job schedule as they normally would, and we're not going to slow it down. So beginning to de-risk all of those sorts of things, and then observing how does it set and age and wear, like through a couple of nasty New England winters. So that's extremely important for validating the product and proving to potential off-takers that it works. And we have what we call internally our sidewalks to skyscrapers plan. So starting with simple, kind of low, lesser demanding applications like sidewalks, and then working up through those more demanding structural applications, reinforcements, vertical construction, eventually higher strength, ultra high strength concrete. Over the next 3 to 5 years, like we want to show all of those proof points that the product can hit, that it's a true general use cement that can be used as a drop-in replacement for Portland cement.
And how are those going? What are you learning from those early projects? How's it performing?
Yeah, I mean, they've been great successes. And what I mean by that is we learned a ton and the concrete came out looking good. The last one that we just did about a month ago, actually, this was our first pour outside of the Boston area when we were doing the retrospective and collecting feedback from, there's a lot of players involved in any construction project. You've got the concrete producer who actually mixes the cement into the concrete, transports it to the job site. You've got a contractor that actually places it and finishes it, gets it level, gets the right finish on it for whatever the application is. You've got the general contractor who's building the whole building and owns the whole job site, the engineer who specs the material, the architect, and the owner. So all these players and stakeholders are involved in any of these, even if it's a small pour, they're all involved. And so when we were just doing the retrospective and collecting feedback from all these different stakeholders, the concrete contractor, the guys that actually placed it, I'm paraphrasing, but their feedback was essentially, it looks like concrete, I guess, that's the best feedback that we can hope for. Is like, yeah, it's a total non-issue, basically. And there are no surprises. Yeah, so.
Nice. You mentioned these partners like Wholesome. I was going to ask about this, and it sounds like your strategy has been to partner with them. I was curious if that was kind of always the obvious path, or was there a potential strategy that would have been put you in more of a competitive position with the incumbents, or is it just necessary to partner with them given kind of their ability to scale and the partnerships they have and all that?
It's the latter. I mean, I think all long-term, all business models are still on the table, but I think if the company was founded to have an impact on climate change and to have we call it a swift and massive impact on the CO2 emissions from cement production. And I mean, time is of the essence. And if we actually want to fulfill the mission of the company and have a meaningful impact before it's too late, we need to get to scale quickly. And the obvious path to that was partnering with these companies that, one, have the capital to deploy. Second, they have the expertise. They are experts at moving millions of tons of rock around the globe very efficiently. And we're a technology company. And so there's a very complementary partnership there. And we don't have to go build out all of those expertise and functions ourselves. So that was, I think, a pretty clear marriage that was going to work to get us to scale quickly.
And what are they seeing? And I guess what are you seeing at Sublime too? That's kind of, eventually you get to cost parity and this maybe becomes an obvious choice. Like might as well use the greener thing. That's the same cost, but there's a journey to get there and a lot of investment and it's going to be more expensive in the meantime. What's driving that kind of demand to get through that process? What are companies doing this because of their net zero commitments or where is that coming from?
I would say looking at the US, there has been very encouraging progress at the federal, state, local, and private level, like tailwinds and inertia building at all of those layers that have aligned with what we're trying to do in market. Obviously, the federal level, there are a few more questions about what that's going to look like, certainly for the next couple of years. But I think that those initiatives and inertia will continue at the state, local, and private level. We are working with a lot of companies that they have, firm internal Scope 3 emissions targets. They have budget to put against solutions to achieve those targets. And so they are already signing offtake agreements for these materials from our initial plant and even our first full-scale plants we're going to build with our partners. Looking at other regions like the EU, you also have the ETS system and an actual cost of carbon. So that helps a lot as well to make newer stage technologies like Sublime cost competitive even more quickly with the existing products. So we are interested in a number of different markets and are looking at those for our roadmap. But yeah, fortunately, we are essentially sold out of our first plant. We have a backlog of folks that want to do paid, commercial transactions and field tours with material out of our pilot plant for at least the next 18 months. So yes, there are questions and we're going to be feeling our way through this new change in the federal direction, just like everyone else. But we are confident that what we're doing, there's going to be the support. I think we are also in a better position than potentially some other companies and startups because our value proposition is, I think, a bit broader than just carbon avoidance. Our process produces a cement that theoretically can be more consistent than what you get out of Portland cement, which translates to more predictable, reliable strengths, potentially more durable. Actually, it's stronger once you get to timelines beyond 28 days of curing, which is what the engineers care about. So if you can produce a theoretically stronger, more durable, more predictable and reliable cement with American technological innovation and manufacturing jobs, that's a pretty strong story. And frankly, is aligned with a lot of what we've heard coming out of even the new administration. So I think we're feeling pretty good about our positioning right now.
Right. So it's not just a sustainability play. It's actually a better product.
Exactly right. We call it next gen cement. So it's low carbon, but it's also just how cement will be produced in the future, or at least how we like to think about it, and has all the kind of beneficial attributes of that next generation product.
I saw a press release about this kind of MOU with Microsoft and the book and claim model. This was new to me, but it almost sounds like Microsoft is buying almost like carbon credits, but paying for the environmental benefits of producing Sublime cement, even if they're not directly using Sublime cement to help offset their emissions. Is that how that works?
Yes. So first of all, I think there is kind of a key difference between book and claim, which I can explain a little bit, and what you typically think of when you hear about carbon credits. So you have the carbon credit registries and marketplaces where they're voluntary marketplaces where various companies can buy credits from forestry projects or things of such nature to then apply against their overall operational emissions from their company's operations. And there's been a lot of credibility issues with those marketplaces, questions about additionality, so on and so forth. Book and claim, it's a little bit of a different beast. So it is the concept, it's a marketplace where the environmental attributes of a low carbon product like Sublime Cement can be sold separately from the physical product. But it is specific and related to like the actual area of operations of the customer that would be purchasing these attributes. So like, for example, Microsoft looking to purchase these attributes to offset their own Scope 3 emissions, and they build a bunch of data centers and a lot of other buildings. And so they use a lot of cement and concrete. However, their building projects don't happen to be in the same place as the first one or two Sublime plants that are going to be built. And so what Book and Claim does is it offers a way of separating these two things. And it's particularly helpful in the early stages of scaling where we need a bit of a scaling premium to cover our production costs while we come down that scale curve. The availability of our cement, it's not ubiquitous yet because we only have one or maybe a couple of plants. And so it allows these customers like Microsoft, who they have these Scope 3 emissions targets, they're looking for new technologies to help them hit those targets, but they're not nearby. They can purchase these carbon avoidance benefits of our cement. And then another customer who's in the immediate vicinity of our plant can use the physical cement and the local supply chain. And so it's pretty similar to what has been developed in the sustainable aviation fuel or SAF market. And so we, as you mentioned, we announced a couple of months ago, we're negotiating a deal with Microsoft for the purchase of, we call them EACs, environmental attribute certificates. And it allows us to work with Microsoft based out of Seattle when our plant will be in Massachusetts. And there are a number of other potential customers that we're talking to about similar type of agreements. Now, it is in the early stages. The SAF marketplace is more mature. Sublime is heavily involved in the development of the rules of how this marketplace is going to operate, the carbon accounting rules. Key is how do you avoid double counting and like what claims can be made by the physical cement user versus the owner of the attribute. And so we're working with the Rocky Mountain Institute or RMI and the Center for Green Market Activation or GMA, which are driving a lot of these discussions. But it's a very exciting part of our business that is going to help us really kind of finance that road to scale more quickly.
Yeah, that's really cool. So Microsoft will be using concrete and cement, but normal Portland cement. But at the same time, they're kind of paying the premium for Sublime Cement and able to claim those environmental benefits. And at the same time, Sublime is going to be producing that cement, and then a local customer in Massachusetts will be able to use that without paying
that's correct.
That premium that Microsoft is covering.
Correct. And I mean, Microsoft, they would love to use the physical cement, call it kind of a bundled product where possible. So if they do happen to have projects that are in the vicinity of a Sublime plant, then they very well could use the cement as well as claim the attributes. But yep, that's roughly the concept. You nailed it.
Renewable electricity, I'm thinking like direct air capture, and green hydrogen is super energy intensive using electrolyzers and electric vehicles. And then we've got AI coming online, like using a ton of energy, although maybe DeepSeek is changing that. But there's just like a ton of demand for green electrons, or we're sort of the future of all these companies is depending on a bunch of green electrons. And we've already seen things like direct air capture facilities getting canceled because they can't acquire enough green electricity to make a pencil. I'm just curious, like, how do you look at that? And I don't know how an energy intensive Sublime's process is, but is that a risk for the future of Sublime? Or should we be looking at technologies like this as really generating demand for those green electrons and it's actually a good thing overall? How should we be deciding which processes get the green electrons? I was just curious if you could help me kind of wrap my head around that.
It's a fantastic question. And I would say it's a little bit of both. So first of all, we're fortunate enough to have someone who is leading our project development of these facilities that we are building, who actually comes from the renewable power project development space. So my colleague, Becky Gallagher, comes from solar and wind project development. And so that is her world and background. And so when we are looking at siting future locations, renewable energy is actually just one of many criteria that have to be considered to make a good site. So others include availability of feedstocks. You need to have quarries and sources of feedstocks that are nearby, access to market. Cement, it is typically a fairly local, regional material. It's heavy, it's not that high value, and it doesn't make sense to ship it across the country typically. So access to market, local incentives, tax incentives, government regulations, those sorts of things. So there's a lot of different criteria. And we have found thus far that, we're looking far and wide. We're looking across multiple continents, really planning out a roadmap of building lots of plants over the next few decades to have that swift and massive impact. And as of yet, we have not found that availability of clean energy is a primary limiting factor. There are plenty of attractive sites where the cost of power, the cleanliness of the grid, the ability to strike power purchase agreements or use RECs or all of the above to get to those clean energy levels that are necessary for our kind of model to work, it has not been a gate. There are fortunately or unfortunately, it also takes years for these plants to get built. And so there continue to be huge amounts of new renewable projects coming onto the grid. And so I think the supply is building as quickly as the demand. But to your point, hopefully seeing that projects like ours are getting built will help then provide the rationale to build new projects and build more power onto the grid over the next 5, 10, 15 years. So it has not been a gate. We don't see it being the gate for the first couple of plants. And I think we're being pretty smart and prudent in thinking about, what is our procurement strategy for renewable energy? And I mentioned some of those instruments. I think every site is probably going to be different. So like, for example, the Holyoke site, it literally is next to a hydroelectric power plant. But there are other sites where they've got great access to feedstock quarries, great access to the market and logistics networks, all those sorts of things where you don't. And that's where figuring out whether we're going to do, direct PPAs or purchase RECs from the local authority, whatever that's going to look like, it's going to be a mix of different energy procurement strategies depending on where the site is.
Thinking about the future a little more, what's your vision or your team's vision for Sublime in terms of kind of the total impact you can have on this industry and on emissions? Is this Sublime will replace all cement in use today, or do you expect it to be, or is your aspiration to be covering a portion of the market when you sort of cast what's the goal here?
Yeah, I would love that. But being a pragmatic individual, I think the idea of Sublime completely replacing Portland cement anytime soon is probably a bit aggressive. But our process, it's just a better way of making cement and lower carbon, yes. But there are also a much broader range of environmental benefits. When you compare a typical cement plant and Sublime, there are lower particulate emissions from our plants. You've got lower NOx and SOx emissions that can contribute to acid rain. And so for example, at our Holyoke plant, there's literally a senior center across the canal from us. And for a typical cement plant where you've got the noise, particulate emissions, the heat, all of these kind of scary things from a cement plant, the Sublime process and plants, it's just a better, smarter way of making cement. And so we do believe that we, with the right financing and time to scale, can replace a meaningful portion of the cement base. As we talked about, it's an easy drop-in replacement, or it's designed to be. But we need all these technologies. I think it's going to be one part new binders and processes for making cement like Sublime, one part carbon capture on traditional cement plants that still have a lot of useful life on them, decades of useful life left on these plants, one part new SCMs coming into the market that can reduce the amount of cement we use. Sublime, VP of product, we don't just make cement. We actually produce our own SCM, which can be used to blend into concrete to replace additional use of Portland cement. So that's a second way in which we can reduce those overall emissions. So I think we have the potential to have a broader impact on the industry as we approach scale.
I have 3 last questions for you that I ask everybody at the end of every episode. The first is, how optimistic or pessimistic are you about the future of the planet and why?
I would say moderately optimistic. I'm a pragmatist optimist, I guess. As I mentioned earlier, I'm a parent. So honestly, I think I have to be optimistic. I think it's pretty easy to get caught up doom scrolling all of the apocalyptic headlines and just kind of curl up into a ball. But there is an incredible amount of change and progress occurring. Some reports say we may have hit peak emissions and may begin declining this year. Renewables are the cheapest form of energy in much of the world and are being deployed at an astounding rate. Over the last few years, just since I've gone into climate, the number of brilliant people I know from tech that I knew in the Bay Area that have reached out because they want to move into climate is incredibly encouraging. So the talent level is amazing working on these problems. And, in the US over the last few years, as mentioned, there's been tremendous action at all levels of government. And I think even with some uncertainty, that's going to continue to accelerate. So there are a lot of real reasons for optimism. Of course, we just all wish it would move faster.
Yeah. Who's another company or individual doing something to address climate change that's inspiring you?
I mentioned I started out in aerospace. I'm also a big aviation nerd, and I've been a pilot for over 20 years, worked in aerospace. So I follow that sector pretty closely as well. And from a climate angle, long-haul aviation, it's another one of those tough to decarbonize sectors. Fully electric won't work. Batteries are too heavy. SAF is part of it, but it's unclear whether the supply can ever serve a meaningful part of the demand. So I'm a big fan of a company called ZeroAvia, which is based out of California and the UK. These guys they're developing a hydrogen fuel cell and electric powertrain for mid-range aircraft. So actually moving not just the fully electric little taxi puddle jumpers that can kind of jump around the city and replace cars, but actually beginning to get into that hundreds of miles, thousands of miles type of range with a zero emission solution. So it's very cool stuff. And I find what they're doing very exciting.
Oh, nice. I'd love to talk to them. What advice do you have for someone not working in climate today who wants to do something to help?
Well, we touched on this earlier, but as I said, climate, it's the entire economy. So no matter what you do, whether you are a lawyer, an engineer, a writer, a marketer, a technician, like whatever, there are ways for you to put your talents to use to help. And so like we talked about a little bit earlier, honestly, one of the hardest parts for me in my own transition was figuring out where do I fit? Like where do I want to help? And I never would have thought that cement is where I would have landed. But after enough coffee chats, podcasts, books, I figured out my path. So my advice is hit your network. I guarantee you at least one of your friends is now working in climate in some capacity. So start there with a beer or coffee chat and see where it takes you.
Yeah, awesome. Good call to action. Greg, that was really fun. I've learned a lot. Thanks a lot for your time.
Me too. It was a lot of fun and hope we can do it again.
Hardware to Save a Planet is brought to you by Synapse. To find out more about us and how we develop hardware solutions for the world's most ambitious companies, head to synapse.com. And then make sure to search for Hardware to Save a Planet in Apple Podcasts, Spotify, or anywhere you like to listen. Make sure to click subscribe so you don't miss any future episodes. On behalf of the team here at Synapse, thanks for listening.